Hi everyone, this is Clément from Nob Foundry. I'm going to give a quick overview of the project and show what we can do with it. The first thing we can do is to get the viewer. Pre-builds are available on the website for Windows, macOS and Linux in the download section. If you're not comfortable with these bundles, you can of course build it yourself. We hope to have the project properly integrated with all major package managers at some point, so if you're a packager, feel free to get in touch with us. Anyway, when we have the viewer up and running, we see something like that. By default, we only have one demo, which is the one running up here, but the point is to be able to load external ones. For example, if we get the Nob demos repository, we can load them from here, which is what I'm doing right now. Inside each script, a bunch of scenes can be exposed, and this combo box is here so that we can choose which scene we want to render. On the right side, we have the preview player, where we have traditional controls to play with the time. On the left panel, each scene may expose a bunch of controls. There are two types of settings. The first one are construction parameters, which basically drive how the scene itself is built. These settings can be slow because they imply the full reconstruction of the graph. Basically, the code inside the script is going to be re-executed with the new settings every time we change a value here. In this case, the geometry is going to be completely different, but it may also fundamentally change the whole structure of the scene graph. The second ones, on the other hand, work with the same render scene and essentially change the value at runtime within that same graph. It gives less controls, but at the same time it's much faster than rebuilding the whole graph like the build parameters do. And last but not least, the scene can be exported into a video file. We do provide a few encode profiles and resolutions. 420 is typically meant for sharing on the internet because it's the most compatible one, but we do have a few other options for higher quality or even lossless outputs if we want to import the video in another video editing pipeline. Now, I mentioned earlier the notions of graphs, which you may be wondering what this is all about. So if we go to the front page, we are seeing again this prototype text intro with some effects, along with some sort of node-based graph. These are the same picture. This is one of the first key aspects of the project. The graph we see here is what the script constructed, and the video is what the engine made out of it. This means that instead of following a bunch of directives to drive the animation, we are working with a declarative approach, where the script code essentially has to create a graph that describes what we want. This is what the scenes we've seen earlier refer to. There are Python functions that construct such a graph. And then the engine gets this graph, and for every video frame, the same graph is going to be evaluated, but with a different time parameter. Let's have a very quick look at the graph to get a rough feeling of what it actually means. Here, the group on top is a root node. That's where the rendering of one frame starts. We then see one large split. In the first branch, on the left, we see a scale, a texture, and a media. This represents the animated background city image. And in the second branch, we see a different scale, but more importantly, we see a text node which contains two effects. Looking at the parameters of this effect node, we can see that both of them target the characters and seem to describe how the opacity and the blur are animated. If we look at the scales, we see that a few time keyframes are described. They indicate how the value for a given time should be interpolated. For example, the background starts at time equals 0, so at the very beginning, with a scale of 1. And when the time reaches 11.5 seconds, it should be 1.4. So the scale is going from 1 to 1.4 in the time scale of about 12 seconds, linearly, like a straight line. According to the rendering time, the engine will then interpolate the appropriate value for each and every frame. So that's pretty much how this simple graph produces a prototype video. Side note here, even though each character is individually animated, the graph is expressive enough to allow you not to describe the animation of each individual character. This means that we can actually change the string in the text node and the animation will adjust accordingly, whatever the number of characters present in that text. It does not require the graph to be reconstructed. So that's it for this quick intro video. If you want to learn more about this project, its history and where we are going, I would encourage you to dive into the website and join us on the usual social networks. Overall, while the engine itself is pretty mature at this point, we are still in the early stages with regards to the overall user experience. We are currently a large team of 2 developers, so obviously there are still some rough edges to polish. The whole framework is free and open source, so you may want to check out the Get Involved website page in particular. We have a ton of things cooking up at the moment, so stay tuned. We have a RSS feed and we are going to be pretty active on Mastodon and other social network, so check out the website footer. And I guess that's it for now, so see you soon. Peace out.